We're going to use the same file as we did last time, reg.pl, and we're just going to make some tweaks to it. And actually, we have it up here. If you'll note, what we've done is we've added the word kiwi at the end of our array of words, just so that we can demo a couple of things that we're going to play around with here in this video. So basically, the array at the end of orange, we have comma, double quote, kiwi, double quote, and then close parentheses and semicolon. And we've added a comment at the bottom of our past examples of a matching and substitution regular expression. And what we're going to use here is a loop to loop across an array and apply regular expressions, or as some people say, regex or regex. So we're going to use the for each loop because it's a fast and easy way in Perl to loop across an array. So we're going to say for each space sigil item space opening parentheses at words, close parentheses, and then opening and closing curly braces. And then inside of those curly braces for the for each loop, we're going to put an if statement. So inside of that, we'll say if space opening parentheses sigil item space equals tilde, or our binding operator, space m slash a slash, and we're going to leave it as that because we aren't going to worry about case insensitivity or it matching multiple times, so we don't need the GRI flag as we saw in the past video. Closing parentheses, opening, closing curly braces, and inside of the curly braces for the if statement, we're going to put a print statement. So we're going to say print space, double quote, we found a match in sigil item, backslash n, double quote, semicolon. Okay. So what this is going to do is it's going to loop through our array called at words, pulling each string out and temporarily putting it in sigil item. It then uses the if statement to run a matching regular expression against that sigil item scalar and print something out if it was able to find that pattern that we're looking for. You'll see in some examples online where they don't have the sigil item at all, and that's because in a for each loop, if you don't provide a scalar to pull each item out of temporarily as it's walking across the array, it uses the sigil underscore default scalar. And actually, regular expressions are in Perl bound by default to sigil underscore that default scalar. So you may see some where they don't have the sigil item at all. It's just the array name, and like for your if statements, if and in parentheses the matching regular expression, and it auto binds to the default scalar. We're doing this for clarity, just so that you can see, hey, it's pulling it out, signaling an item, and we run our matching regular expression on that sigil item. All right, so let's save this and run it. And since the pattern we were searching for is the character A, or the letter A in a lowercase, we should get pretty much everything except for kiwi, because all of the other words had the letter A in it. So let's jump back in and let's change up our pattern a bit. So what we're going to do is to search for a letter or a pattern at the beginning of a string. We're going to add a caret. So we're going to change up our pattern to be m slash caret, which is that sort of little mountaintop character, and you have to hit shift and the number 6 in order to get it. So m slash caret a slash. Well, let's save this and run it again. And we should just get apple, because that's the only word we have in there that starts with the letter A. So let's change this up again. And we're going to, instead of a caret A, we're going to make it A and a sigil. And that sigil basically says look for this pattern at the end of the string. So we save it and rerun it to get banana. That's the only one that has A at the end. And you can, we're playing around with one letter. You could actually do multiple letters. So if your pattern was caret A-N-T-I, that would search for the prefix anti or anti at the beginning of a word or a string. Okay? So there's different ways of playing around with this and tweaking it. Search for suffixes, all sorts of different things. All right, let's change up our regular expression a little bit more. Change up that pattern. And what we're going to search for now is, let's do something like this. Let's get rid of the sigil, and we're going to put inside a square, we're going to have m slash opening square bracket, A-E-I-O-U closing square bracket, slash. And what that's going to do, your square brackets are used to say, hey, match any of these characters. Okay. So AEIOU is going to search for any vowels. Okay. Now, this being the English language, I'm trying to think if there's any word other than like titles and abbreviations that don't have vowels. Cannot think of anything off the top of my head. I don't think there are any, but I could be wrong. Anyway, we're going to search for, hey, there's a vowel in here. So let's save this and run it. And we should basically get hits on every single word because they all have vowels in them. You use the same pattern to say, hey, I only want to look for like 0, 2, 4, 6, 8, to only look for those numbers. So there's different ways of saying, hey, whatever's inside of these square brackets, these are the only things I want to match. Okay. You can also do things this way. Like if you have a range of characters that you want to match, let's get rid of the AEIOU. Let's change up our pattern again. And we're going to put W-Z. So basically search for the characters W through Z. When we save and run the program again, we should basically just get Kiwi because it's the only one that has the letter W, X, Y, or Z in it. Let's change things up a little bit more. And what we're going to search for this time is we're going to say, get rid of these square brackets and the W-Z. Because if we didn't have the square brackets and we had like M/W-Z/, it would actually look for a W, a dash, and a Z right next to each other. Okay? So the square bracket basically says look for this range of character. Now we're going to change this up. And what we're going to do is we're going to go in and we're going to say A, or we're in square brackets, we're going to put square bracket A, pipe, or the vertical bar, I, closing square bracket. And basically, it's going to look for A or I. Now, this could also be achieved using just A and I, but you'll see in some examples where you have more complex structures where they're looking for A or I, and that vertical bar acts as an or. I know in a lot of other languages, like full-blown Perl, the double pipes mean a logical or, but regular expressions being a subset of a language, you can use a single pipe to act as an or. So if we say A or I inside of square brackets, and let's go ahead and toss a sigil on the end of that. So it's M/ square bracket A, pipe I, square bracket sigil slash. That's essentially going to look for A or I at the end of the word. So if we save this and run it, we should get banana and kiwi. Okay. So you can combine, and you'll see online, if you search for some examples, you'll see all sorts of different ways where you can define different patterns. So there's ways of saying, hey, I just want to search for an email address, or I want to find this specific pattern and replace it. This is useful. I mean, if you're thinking of like parsing genetic code, you can use regular expressions to do that, because it really is, with a matching regular expression, it's just a find. And we could, of course, change this if we wanted to be a substitution regular expression and actually replace what was found with some other pattern. And you can do the same sorts of things in your matching pattern that you do in your substitution patterns. So fairly powerful. I'd say play around with it. Feel free to use this and other examples online and provide it to you to get a feel for regular expressions and how you can use them in different manners or different ways to do find and replace or just find. That's it for our regular expression videos. Thank you.